Hello everyone, welcome back. In this lesson, we're going to look at finding a confidence interval for paired data. This is called the paired t interval. And recall that the assumptions for the paired t methods are the paired data condition, which means that the data must be paired or be dependent. And for the independence assumption, we need to assume that the differences are independent of one another. And then we also have for the normal population assumption, where the differences must be normally distributed. Okay, so the way that we will find our confidence interval is by the following methods. So we will calculate d bar. This is the mean of the differences, and then we will add and subtract a critical value times the standard error of d bar. Okay, so the standard error of d bar is given by the standard deviation of the differences divided by the square root of n, and the critical value will depend on the level of confidence as well as the degrees of freedom. The degrees of freedom is n minus 1, where n is the number of pairs. So let's have a look at an example for finding a paired t interval. So here we have field workers for a health department compare driving mileage on a 5-day work schedule with mileage on a new 4-day schedule. To see if the new schedule changes the amount of driving they do, we'll look at the pair differences in mileages. Find a 95% confidence interval for the mean difference in mileage. So here we have some data on the field workers for their 5-day mileage and 4-day mileage. And we also calculated the difference between them. So we took the 5-day mileage minus the 4-day mileage. So now let's go ahead and calculate our confidence interval. So the first thing we'll do is check the assumptions and conditions for using the paired t interval. So the first condition is the paired data condition. Okay, so we must have paired data for using the paired t interval. So we have paired data since we have the 5-day and 4-day mileage from the same driver. Okay, so these data are paired since they come from the same driver. And now the other assumption is the independence assumption. Okay, so we need to assume that the differences in mileage are independent of other drivers. All right, so now to check for independence, we're going to look for randomization. Now we're not given that these samples were random, and so we need to assume that the sample is representative of the population. Okay. And the other assumption is the normal population. So we need to assume that the population of differences is normally distributed. So to check for this assumption, we'll look for the nearly normal condition. So the sample distribution of the differences should be unimodal and symmetric. And this can be checked with the histogram. And we want to make sure that there is no extreme skewness in the distribution. Okay. All right, so now we'll go ahead and calculate the confidence interval. So now the first thing that we'll need is to calculate the mean and the standard deviation of the differences. So here we have the differences. Okay, so we'll first calculate the mean and standard deviation of the differences. Okay, so the mean of the differences is going to be 982, and the standard deviation of the differences, which we'll denote by SD, this will be 1139.56833. Okay, so now we can calculate our confidence interval. So we will have the mean of the differences, so d bar, plus or minus a critical value times the standard error. Okay, so to find our critical value, we need the degrees of freedom, which is n minus 1, where n is the number of pairs. So here we have 11 pairs, which gives us 10 degrees of freedom. So now we can go ahead and use our t-table to find the critical value. So we're looking for a 95% confidence interval with 10 degrees of freedom. So this tells us that the critical value is 2.228, and that is for 95% confidence. Okay, so then we need the standard error, which is the standard deviation of the differences over the root of n. So what we have is 1139.56833 divided by the root of 11. Our standard error will be 343.592. And now we can go ahead and calculate our confidence interval. Okay, so we have 982 plus or minus our critical value, which is 2.228 times the standard error, so 343.592. So this will give us 982 plus or minus a margin of error of 765.524. And so our interval is from 216.48 to 1747.52. Okay, so then what we can say is that we are 95% confident that the true mean difference in mileage between a 5-day and 4-day work schedule is between 216.48 miles and 1747.52 miles. Okay, so notice that the confidence interval is entirely positive. And the way that we calculated the difference was taking the 5-day mileage subtracted the 4-day mileage. Okay, so if the difference between the 5-day mileage and the 4-day mileage is positive, then we know that the 5-day mileage is larger than the 4-day mileage. And so this interval suggests that the 4-day mileage or the 4-day work schedule reduces the mileage driven by the field workers.